Hello guys, and welcome to this new video. In this video, we'll be talking about the two types of Tesla coils that we have, the slow capacitor circuit and also the spark gap Tesla coil. And I'm going to explain how it works, the component that I use in this two structure of Tesla coils, and also the uses of it. Now let's just quickly go into the explanations of the Tesla coil, the component that I use, and everything you need to know about Tesla coils in their forms. Let's go into it. Welcome back. The first Tesla coil that I will explain is a spark gap type of Tesla coil, which I'm going to first explain how it works and also the component that I use in this Tesla coil. Okay, this Tesla coil comprises of a secondary coil, a primary coil, spark gap, then a capacitor, and a high voltage transformer. Okay, let me quickly connect the circuit and explain how it works. Okay, now I'm done with the connections. Let's explain. First off, when you put your 230 volt AC power supply right here, it feeds into the high voltage transformer and produce about 20,000 volts that is gone to the capacitor, that charges the capacitor. Already one of the terminals of the capacitor is connected to the high voltage output. So the other end of the capacitor is connected to the high voltage output, and this way. This end passes through this primary coil, then those directly move like this, and yep, that's how it's connected. The other leg of the capacitor is connected to the high voltage power supply. High voltage output through the primary coil. So when the capacitor charges, it charges to its peak voltage, and when it reaches this peak voltage, it releases the voltage in the spark gap terminals. At this spark gap terminals, it now causes a spark that shorts the voltage of the capacitor, and again this output of the high voltage charges the capacitor, and this process begins again and again very fast. And for it to make it very fast, we are going to use a very little UF of capacitor. In my case, I'm using a 3.3 UF. That will be pretty much cool to make it very fast in its charge and discharge. So when it charges, it shorts, charges, it short. This cycle continues again and again very fast, and also sends a pulse voltage in the primary coil that induces electromagnetic field into the secondary coil. That now we have our spark out of the other end of the secondary coil. Then the end of the second coil is connected to ground to prevent and protect the circuit. So this is how it works in this manner. So this is how the spark gap Tesla coil really works. So let's just jump into the other type of Tesla coil, which is the slow capacitor circuit. Right now, I'm going to draw the component that I needed. We also need a secondary coil in this slow capacitor circuit. We need a primary coil, and there is a new component that will be included, which is the transistor, NPN type. In my case, I use the 2N222 transistor because it has high frequency changing. Okay, yes, this is the base, this is the collector, and this is the emitter. Also, we're using a 22K resistor in my case. Also, LED diode. Also a 9-volt power supply. Okay, now let's quickly connect this circuit and I'll explain how it works. Okay, now I'm done with the connectors. Let's show how it works. Okay, first, when power pass is applied in the power supply, which is 9 volts I'm using, 9 volts, it passes through the resistor and quickly goes into the base of the transistor that closes the collector and the emitter, and this directly owns the primary coil, because the other end of the primary coil is already connected to positive. So when the collector and the emitter closes, it just connects the other end of the primary coil to ground, just like this. So when it is connected, it induces electromagnetic field, just like the spark gap manner, into the secondary coil that now have voltage in it. And in this case, the other end of the secondary coil now have a negative charge. It has a negative charge that goes into the transistor base. Because the transistor is an NPN type of transistor, when negative is applied on the base, it's off the transistor. In other words, it draws the transistor low. So when it's off the transistor is off and this primary coil is no longer powered. Then when the magnetic field in this secondary coil keep on reducing, the polarity changes, it changes. And this negative changes to positive, and then passes through the base again and turn on the base. And when it owns the base, it connects the primary coil again, and this process begins again and again and again very fast. And this is how these two Tesla coils practically works. And also this LED diode is for preventing the base and the emitter voltage from exceeding its limit. So that's just the use of this Tesla coils. This is how it works, and this is how they made it. Okay, welcome back. Don't forget to like, share and subscribe. I hope you really enjoyed this video. Thanks for watching and bye for now.